In this tutorial, we'll create a custom project to analyze DNA cell cycle in yeast samples. As shown in the diagram, yeast cell cycle is quite different from mammalian cell cycle. ModFit LT's automatic analysis was not designed to analyze samples from yeast populations. However, ModFit LT allows the user to create models from scratch for novel applications, and we can create a project to organize the model, sample files, and the output we generate. We will use a yeast model previously developed and learn how to incorporate the model into a new project. I'm going to start by creating a new project. This is going to be a custom project. I'll give it a name. The project will be stored in our Documents ModFit LT Projects folder, and I'm going to enable this option to copy data files into my project so that they are organized with the rest of my project files. When I click OK, I have a blank report, an empty list of files, and a set of options for how I want to analyze the data. I'm going to open a document that has the yeast model in it. I'll use a drag and drop to do that. So here is our previously created yeast model in a report showing us an analysis that was done by an earlier version of the software. To make this part of my project, all I need to do is to resave the project at this point. This will store a copy of this document in the project, and it will be used as our template for the analysis of data files. Next, we'll select the FCS files to analyze. I click the Open FCS button. These example files are shipped with ModFit LT, and they're found in the Samples Yeast folder where the program was installed. When I read the files, they're added to the batch list here, and the first file is read into our report template. We can see there are two gates in this. There are two views of the analysis population, a normal view and then a zoomed view. What we need to do next is make some choices about what we want the analysis to do. That's done in this panel over here. Here we can see again, this is a custom project type, and the analysis is going to fit with this current model, the model that is contained in our model template. We're going to enable Save Report and Save PDF, which will be stored in our project output folder. So now I'm ready to analyze this first file. It's already opened, so let's walk through that process. Once the file is opened, the first step is to make sure that the gates that we're using here are properly set. Gates can be adjusted by grabbing them and moving them. You can also reshape them. These gates look like they're in pretty good positions. After moving the gates, we've got one more step to perform before we do analyze it. We'll switch to the range view. Here we can see 4 ranges that are used to provide estimates to the model. The 2C range is positioned over the first of the yeast populations. The 4C range should be at a position about twice that. So you can see here this peak is at about 200. This one should be at about 400. This should be centered, the 6C should be centered at about 600 in this case, and the 8C should be centered at about 800. Don't get too worried about the analysis at this stage. These are just estimates. To see whether the model is going to fit correctly, we'll click the Fit button. The program switches us back to Analysis view, and we can see how the model actually fit the data. We have our 4 peaks identified, and then between each of the peaks is an S-phase compartment telling us how many of the yeast cells are in synthesis. On the right, we see the model's statistical results based on the fit. Before we move on to our next sample, let's create a database for this new model that we've incorporated into our project. I'm going to go to the Edit tab and choose the Database Wizard. The Database Wizard looks at the model that is currently loaded and the fields that were created for it, and it automatically adds fields, appropriate fields, to the project database. In this case, it added 28 fields, and it provided us with a viewer so that we can see the results as we move through the files. So we'll move to the next file now by clicking the Next button in the Batch toolbar. And once again, our process is to start by looking at the gates. This gate looks like it's in a good position. This one is too. Second step is to switch to the range view. And here we may want to adjust our ranges just a little bit. That one looks fine. We choose Fit when we're ready, and our analysis looks good again with this second yeast sample. On to the next. We click the Next button and review the gates. They look like they're in a good position. Range view, make sure the ranges look good. They look fine. We click Fit, and here's our third file's analysis. And we'll finally move to the last of the files. We can check our gates. In this case, we might want to slide this down just a little bit so that we eliminate these events on that tail there. We move to the range view, check our ranges. They look like they've identified the peaks pretty well. We might slide this one out a little bit. And then once again, we click Fit. At this point, we have database results for all 4 of the samples. As we moved through them, we created reports and PDFs, which we can review right now. If I want to go back and see the report or PDF for any one of the files, I can just double-click on that entry in the list. And here's a choice of choosing to open a PDF, open the report, or reanalyze the file. If I open the PDF for that analysis opens into your default PDF viewer. If I choose Open Report instead, ModFit LT reads that saved report in so that we're back in the state where this file was analyzed. We can make additional adjustments if we need to. And that's all there is to it. This is using a custom model in a ModFit LT project.